Hello everyone, I'm here to introduce how I figure out the first part of the homework 10. First, let us see the question itself. From lecture notes, collection definition and simple properties of the example of stochastic process. First is Poisson process. The number of t1, t2 of the points ti in the interval t1, t2 of the length t equals to t2 minus t1 is a Poisson random variable with parameter lambda t. So we can get that the Pn t1 t2 equals k is equals to e2 negative lambda t times lambda t2 k divided by k times k minus 1 to 1. And if the interval t1, t2, t2, t3, t4 is not overlapping, then the random variable t1, t2, nt1, t2, and nt2, t3, t4 are dependent. And the mean ext is equal to lambda t. As for the autocorrelation, rt1, t2 is equals to lambda t2, t1, t2 plus lambda mean t1, t2. And autocovariance is equals to ct1, t2 is equals to lambda t1, t2 plus lambda minimum t1, t2 minus lambda t1 times lambda t2, that is equals to lambda minimum t1, t2. And second, for the Poisson increment process, that is yt equals to xt plus epsilon minus xt divided by epsilon, where xt is the Poisson process. So the pyt is equals to n divided by epsilon is equals to e2 negative lambda epsilon times lambda epsilon to n divided by n times n minus 2 times n minus 1 to until it time to 1. And the mean of it is equals to lambda. As for the autocorrelation and autocovariance, that is rt1, t2 equals to lambda 2 when t1, absolute value of t1, t2 is more than epsilon. Otherwise, it's equals to lambda t2 plus lambda divided by epsilon minus lambda times t1 minus t2 divided by epsilon t2. And ct1, t2 is equals to 0 when absolute value of t1, t2 is larger than epsilon. Otherwise, it is equals to lambda divided by epsilon minus lambda times t1 minus t2 divided by epsilon t2. As for the point impulse process, at equals to the derivation of xt. Xt is also a Poisson process. The mean of it is equals to lambda, and the autocorrelation is equals to lambda to 2 plus lambda to the step function of t1 divided t1 minus t2. The autocovariance ct1, t2 is equals to lambda times step function t1 minus t2. As for the semi-random telegraph sign, the Pn t1, t2 equals to k is equals to e2 minus lambda t times lambda t to k divided by k times k minus 1 times k minus 2 until time 1. In this case, the xt is equals to 1 when k is even in 1 to t, and equals to negative 1 when k is odd. And the mean value of it is equals to e to -2 times lambda t, and the autocorrelation is equals to e to -2 times lambda absolute t1 minus t2, and say t1 t2 is equals to e2 minus 2 times lambda absolute t1 minus t2 minus e2 -2 lambda times t1 plus t2. For the random telegraph signal, yt is equals to lambda xt. 1 p lambda equals 1 equals p lambda equals -1 equals 0.5. When xt is a semi-random telegraph signal, as we mentioned above, the mean value of it is equals to 0, and rt1 t2 is equals to the ct1 t2, that is e2 -2 times lambda times the absolute value of t1 minus t2. And 6-1, the random work, that is, suppose we toss a coin n times and the k numbers of hands-on. So the x and t is equals to ks minus n minus k times s, that is 2k minus n times s. So the mean value of it is equals to 0, obviously. And the autocorrelation is also equals to the autocovariance, that is equals to the minimum value of n and m times s22. And for the winner process, we already know that wt is equals to the limit of t to infinity for xt. That is, xt is a random work, as we mentioned above. So the mean wt is equals to 0, and the rt1 t2 is equals to ct1 t2 equals the minimum value of t1 t2 times lambda. Thank you.